iPad and iPhone portion of Rndr is incredible. There's 100 million devices. We can run an iPhone 11. We can run Rndr net jobs, both real-time, locally, on an iPad and on an iPhone. And an iPhone 11 is actually pretty powerful. It's basically about the speed of an Intel integrated graphics chip, the same thing that half of Adobe Creative Cloud users use for Photoshop. It can render final rendering scenes. And Apple's put a huge amount of GPU memory on most of these devices. So my iPad M1 has 16 gigabytes. That's double most GPUs on the Rndr network today. And we have real-time capabilities as well that we're bringing to AR. So this is some of the scenes that you were seeing before, running in ARKit on an iPad. It looks beautiful. We want to basically deliver, obviously, high-quality offline content, but this kind of stuff running on an iPhone or an iPad and potentially in some form or another, maybe in glasses, that's really critical.
Welcome to DHN Crypto. On this channel, we focus on global crypto adoption with an added global perspective. If you enjoy unbiased, fact-based crypto content, subscribe and turn on that notification bell. You'll never know which project I'll cover next. The Rndr network specializes in the creation of CGI. Using Rndr, companies and individuals can build computer-generated assets that serve multiple functions. Initially, Rndr started out on Ethereum, performing the heavier workload on ETH's Layer 2, Matic. However, in the summer of 2022, talks began about moving the Rndr network to the Solana blockchain. 24 hours ago, that decision was finalized in a community vote. In this video, we hear from Jules Urbach, the creator of Rndr. He gives us a rundown of the network and the immediate plans for the chain once they move to Solana.
So obviously I'm here to talk about Solana and why we're so bullish on it. So let me start by saying that we started on Ethereum Layer 1. We moved to Matic because the gas fees were so high, they changed to Polygon. And we kind of like it, but there are problems that we're seeing on side chains, right? So Solana solves so many problems at once. For one thing, we want to be able to write high-performance code. That means C++, Rust, open shader language, we write our own compilers, and all those pieces need to run on GPUs, but also on chain. And we can do that with Solana. The VM can basically take C++ or Rust code and turn that into a smart contract. The other thing that's critically important, most of the forward-looking work that we're doing on Rndr is for real time. Even though we're talking about massive amounts of GPU rendering, we want to pull those GPUs together and deliver a real-time stream. You'll see why that's important in a little bit. But we need to be able to change and share states for thousands of users in a scene on chain. And there is no trade-off between speed and security other than Solana. We've looked at everything, and Solana is actually delivering what we need for that. So if you're talking about powering a metaverse, where even if it's just bounding boxes, not complex physics, just bounding boxes, collisions, that's something that Solana can handle. I haven't seen that on any other chain. And if the speed is kind of approaching that, it's because you have too few nodes, and security is put at risk. So for us, the security that Solana offers at this speed is incredible. That's really what sold us on this very important migration. And for us, forward-looking things on Rndr that are focused on real-time are going to be done on Solana. And while we have Ethereum and Matic and all those things, there is that bridge. That wormhole will allow us to keep that data. But there's so many benefits that we get when we're looking at Solana as our primary chain. And now I want to show a little bit about where the NFT trajectory has taken us this past year. So we have Beeple, we have Pack, building and creating beautiful pieces of art in Octane and on the Rndr network. And where things are sort of heading is that, as I mentioned, is streaming, right? So we want to be able to deliver the high-quality work that you're seeing in those, in those films and TV shows as a pre-computed light field or stream that can play back in AR and VR. And we have many partners. We have Disney and Warner Brothers and Discovery and others as investors. And we've been building this content pipeline for VR for years, but now we have other opportunities both with the blockchain streaming, AR, and mobile. And the reason why streaming is really critical is you're looking at this Batcave scene for Warner Brothers, and that is an actual render from the Rndr network, but it's also pulling in streams. It's pulling in live web pages. It's pulling in Unity games. And you can embed a Unity game like this Atom demo inside of your Facebook newsfeed. That was something that we pioneered years ago. And you can then bring that Unity game remotely, locally, into a texture. This is what the metaverse is. This is how the metaverse is going to work. You're going to have 2D and 3D spatial relationships, but they're all going to render within each other. And we've had the benefit of working with pretty smart folks like John Carmack at Facebook. 6 or 7 years ago, actually, we did launch a contest with Carmack and Facebook called Rndr the Metaverse. And here we are. So I want to talk a little bit about how developers can use the Rndr network. So we have something called the Rndr SDK. It's a fully portable graphics API. It allows you to compile pretty much all the code you want, and we dog food that. All the rendering that you saw, all those beautiful graphics, they're all done in a render that we built on this very same framework, and it runs on iPhones, it runs on anything, AMD, Intel, and of course NVIDIA. You can create really complex pieces of code, AI, ray tracing, of course, and we have our own compilers, and it's all node-based. So this lends itself incredibly well to decentralized rendering, but also to decentralized composition for things like virtual worlds. And another really important piece that we're going to be doing with Solana, one of our engineering groups has been working on GPU compiling technologies, have taken it all the way to having C++ code and LLVM code basically cross-compiled to GPU and to chain. But Rust is a really interesting language, and we are going to fund an open source Rust compiler that's going to be an extension to the Rndr SDK. So if you want to run and create really secure code, and in our case, we want to open this to everyone, right? So C++ isn't necessarily the best, safest language to do that with. Rust is going to be an option. And once that work is done, this is something that the entire Rust and Solana community can leverage. And they can leverage it with Rndr or without it. But it's something that we feel is so fundamentally important, we couldn't skip that. I want to show an example of multiple renders running on the Rndr network. This is Octane, our renderer. And in a split second, I'm switching to Arnold, third-party renderer. It plugs in. The Rndr SDK actually makes this happen in real time. You can even mix renders. You can take the Unreal Engine. You can take Blender's cycles and mix these things together. So while we pioneered GPU rendering, and I think we do a great job, we're going to let every renderer in the world use this system. And you're going to see more than just these first two. There's going to be many, many others that'll follow. And we have an open source spec called ITMF. This can leverage both data and also allow APIs to leverage the rendering network for real-time, offline, anything. And Unreal and Blender, because they're open source, are really interesting, and we want to integrate those inside of our system in the next year. I think the iPad and iPhone portion of Rndr is incredible. There's 100 million devices. We can run an iPhone 11. We can run Rndr net jobs, both real-time, locally, on an iPad and on an iPhone. And an iPhone 11 is actually pretty powerful. It's basically about the speed of an Intel integrated graphics chip, the same thing that half of Adobe Creative Cloud users use for Photoshop. It can render final rendering scenes. And Apple's put a huge amount of GPU memory on most of these devices. So my iPad M1 has 16 gigabytes. That's double most GPUs on the Rndr network today. And we have real-time capabilities as well that we're bringing to AR. So this is some of the scenes that you were seeing before, running in ARKit on an iPad. It looks beautiful. We want to basically deliver, obviously, high-quality offline content, but this kind of stuff running on an iPhone or an iPad and potentially in some form or another, maybe in glasses, that's really critical. And to make mixed reality work, it's more than just rendering. We need to be able to take all the data coming from an iPhone or an iPad and use that to blend and relight the scene. Now, some of those things are handled by the phone, like tracking, for example, with markers. But other things are harder, like relighting, shadows. Like you're seeing an example of an asset that's basically being relit by the phone, and the Rndr network can send it to the cloud for rendering, or it can do it locally, and it can mix those together. So this is an interesting example. This is taking, that silver robot is totally rendered. It's coming from Rndr, and it's taking that TV, which is running live, and it's doing ray tracing on that. So this is something that if you imagine social networks, TikTok, Snap, Facebook or others, having this capability where you can take all that power of the Rndr network and blend that with reality on a phone, live or on the cloud, that's pretty good. And we've been improving this technology steadily as we've worked with Apple. We've added things like motion blur, which is pretty cool. It's just gotten better and better to the point where you'll be able to make pretty great movies on your iPhone, but you're going to need the Rndr network to do that for final frame rendering. And this is an example why. We have these incredible viral videos that have been done even before the NFT craze. Like this one got 10 million views. This was done on a desktop. On the left, we can now do it on an iPhone. And the Rndr network will basically make this quality happen from your local device. You can be a filmmaker with an iPhone and don't have to learn all those other 26 3D tools to do this kind of content. All of it done in our software. And while we have final rendering for these effects on the right, you're going to see the iPhone rendering that very same scene live. That's me holding that phone, and it looks beautiful. So, we need basically this massive amount of GPU power to basically allow your phone, these AR devices, to sort of interact with the world around you and to deliver these experiences. Now, you can set up these scenes, but when you're talking about rendering massive virtual worlds, beautiful pieces of art, or IP that's absolutely phenomenal, that's where you need more memory, and you want to have this decentralized compute power. So we've been building these archives for artists like Beeple and Alex Ross to give them a way to sort of put all their content, their life's work, inside of an open metaverse. So we have a data format that is called ITMF. It stores all this data. Artists like J.J. Abrams use the same system, and we have this beautiful content that's been sort of put together this year that isn't just about archiving and creating NFTs. In fact, it's not even about that. It's about allowing these pieces of art from 2D artists and 3D to be mixed together and to sort of show the way towards interoperability. And we have things like 3D scan data, paintings that we need to turn into 3D models through AI. And it's kind of a future playbook, I think, for the metaverse. Like, we need to be able to deliver tools that allow artists to sort of create things without the pressure of NFTs. I mean, Beeple only does about 2 NFTs a year, but he obviously does 365 and a quarter every day, right? So for him, the Rndr archive, and this is something that he contributed enormously to, is all about providing a tool chain where his entire body of work is just stored for posterity, right? And when he does something inside of our tools or on the Rndr network, well, that data, everything, the Photoshop layers, the Cinema 4D file, and of course the rendering, when he does a post, that work is there. You can then explore that piece of content. You can edit it. You can bring it into 3D tools. You can put it, into AR, which we're going to show here. And this changes the game. I mean, NFTs aren't just a 3D model or a video or a static file. They're the entire graph of composition that goes into a Beeple piece. Or in the case of other artists, a painting or Photoshop layers. But all of these things are composable, not just in 3D space, but time and in 5-dimensionally, right? If you have a thematic theme, this will work. We also have future devices like holographic displays, which I think people didn't take seriously until Beeple showed Human One, right, which is this physical display using OLEDs. But the future pieces of physical NFTs, you're going to have these kinds of displays, and so will our iPads and our phones. And holographic displays, this is a simulation. It's like looking out of a window. You don't have to wear glasses. There's no head tracking needed. It just gives you a pure light field, and there's nothing like it. Now, to render on these devices is about 1,000x more than 4K. So you need a lot of compute power, either locally or on the cloud or on the Rndr network, to deliver these experiences. But fortunately, as we see the Rndr network grow and the cost of rendering go down, we'll be able to map these holographic display panels to render jobs and even provide solutions for real-time integration. But these holographic displays, that's the future. You may not need AR glasses when you have these panels that are as cheap as OLEDs are today. And that will happen in the next 10 to 15 years. And that brings us pretty much to the Star Trek holodeck. And the last Rndr archive I want to show and talk about is the Roddenberry archive. It's something that I've been working on with Gene Roddenberry's son, Rod Roddenberry, my best friend, for 20 years. But the last 4 years, in earnest, we've been archiving all of his content materials. And interestingly enough, we've also been building 3D models. All the blueprints for the Enterprise, for example, the team that worked on it, they've been building this on the Rndr network. And that's what Apple showed 2 weeks ago. So this is the Enterprise on Rndr. It's not as good as the movies. It's so much better. Every single detail of this ship has been created. The entire solar system, every crater on the moon, all the stars. It's massive amounts of data. It's hundreds of gigabytes. And the ship itself is just beautifully created. And this is the kind of thing where if you're going to define what the metaverse is, you don't want to build a world. You want to build an object And you want that object itself to define how it works in the metaverse. You take another object, you take other things, you take the planet Earth. How do these things work together? Well, if we have the enterprise and we map out its 40-year history, its world line, we map every single frame of video and TV footage to something in 3D space that we can then pull back and render, which is what you're seeing here. It looks pretty good. That's Star Trek 1, Star Trek 2. That's running on an iPad. And it's incredible, the fact that you're going to be able to go through the entire Star Trek universe, the history of that Enterprise ship, and see it from any angle and participate in it. It doesn't even matter what you can do with it. At the very least, it'll give you the narrative history of Star Trek with perfect fidelity. And there's another thing. It's modal reality. In other words, when you see the show, and when you see Star Trek, you can also pull back into the real world and see the sets, see where it was filmed. And you have this transposition, which is pretty phenomenal. So I'm going to close out by just showing some new beautiful renders from the 1960s version of the Enterprise. I mean, it's just massive details. This is Kirk's head, this is Kirk's room. It's just incredible. And the last bit I want to show is where things are heading. So we're going to have to fill that Starship Enterprise with people and characters and actors. And Rndr will be able to do that. And this image that you're seeing is a synthetic character, and it's using a ton of GPU power. But we will be able to bring that entire universe to life. And that's the future of avatars and humans in the metaverse.